Alright, we're going to do problems number 17, 18, and 19 from the Geometry Chapter 3 self-test. So here's number 17. 17a says, what is the slope of the line with equation x plus 3y equals 17? So if we want to find the slope, one of the ways to do that, and the way that I'm going to do is I'm going to put this equation into slope-intercept form. So what I'm going to do is take the equation, x plus 3y equals 17. We know that slope-intercept form is y equals mx plus b, so I want to solve for y or get y alone or isolate y on one side of the equation. A lot of ways you can say that. And what I'm going to do to make that happen is I'm going to subtract x on each side. That's what I did. I took this x, it's a positive x, so I subtracted x from the left-hand side, which is why down here it's gone. And on the right-hand side, we had 17. We subtracted x from it, but we can't subtract x from 17 because they're not like terms. So that leaves us with the negative x plus 17. Or you could write 17 minus x, but I'm writing minus x plus 17 to leave it kind of, when we get to slope-intercept form, it's a little bit more familiar to us. So we have 3y equals negative x plus 17. This is not in slope-intercept form yet because y is not alone. We're multiplying it by this 3. So to undo that multiply by 3, we are going to divide by 3. So when I divide by 3, this is what I get. And this doesn't look much like this, and we'll talk about why here. We get negative 1 over 3x. Because there's a negative 1 in front of this x here, if you divide that by 3, you get negative 1/3. And we have to make sure that we divide the whole right-hand side by 3, so we're not just dividing the x by 3, we're also dividing the 17 by 3, which is where the 17 over 3 comes from. So this is our equation in slope-intercept form. But they just want to know what the slope is. If you look at this, and this is slope-intercept form, we can see that the slope of this equation is the coefficient of x, or the number that's in front of x. And in this case, that number is negative 1/3. So the slope of this line is negative 1/3. B asks us, what is the slope of a line perpendicular to the line in part A? Well, we first need to have the slope of the line in part A, which we know is negative 1/3. And perpendicular slopes are opposite reciprocals. So I'm going to take the opposite reciprocal of negative 1/3, which is 3 over 1. I took the opposite of it because this is a negative number, so this has to be a positive number, and it is. And then the reciprocal is when you flip or switch the denominator and the numerator, flip the fraction. So the 3 gets switched with the 1, which is what's happening here. These are opposite reciprocals, so these are slopes of lines that are perpendicular. And 3 over 1, you can leave it like that, or if you want to simplify it, it can be simplified to 3. So what is the slope of a line perpendicular to the line in part A? That would be 3. Number 18 says in the figure below, R is the midpoint of the line segment SW. This is the line segment SW. Even though it's a line drawn here, they're talking about the segment SW. So from here to here, R is the midpoint, which means R is in the middle. We want to make a conclusion and justify that conclusion. Well, the one conclusion that can be made here is that SR, this distance right here, or this line segment, is equal to RW, or this distance right here. You could say either one of those things. You can talk about the distance, or you could talk about the actual line segment, that they're the same. And why can we say that? Why is it okay for me to say that SR is equal to RW? Well, it's okay because R is the midpoint of the segment SW, and a midpoint bisects a segment. That's what the definition of a midpoint is. If we talk about a midpoint, that's saying that this is right in the middle of S and W. So therefore, these two segments must be the same. Number 19 says, referring to the figure, we have angle 2 and angle 3 add up to 90. So these two angles right here add up to 90, and that's clear from the picture because we have this little square, the little box in there, which indicates that this angle is 90 degrees. So we're told that angle 2 and angle 3 together add up to 90. Why is it okay for angle 1 and angle 3 to add up to 90? Well, if we look here, angle 2 and angle 1 are vertical angles. If we kind of eliminate this ray here, we look and we have just an X. And vertical angles are on opposite sides of the X here. So that's kind of the description of vertical angles. So we know that angle 2 and angle 1 are the same measure. And we're replacing this 2 with this angle 1. Why is it okay for us to say that? Well, We know angle 1 and angle 2 are vertical angles from the picture. And therefore they're the same measure because that's what vertical angles are. So what says that we can replace this 1 with this 2 is the substitution property of equality. Since we know that 1 and 2 are the same, it's okay for us to substitute 1 in for 2, and we still get something that makes sense, or something that does still add up to 90 because 1 and 2 are the same thing.